like we said in the last one, so this is for transformer connections. So this is just a primary and a secondary. This is one single phase transformer. That could be on a pole, okay? And you have 3 of these, and this whole thing right here is A phase, all right? So just remember that you can make your connections like this. So let's just give credit where it's due. And this is for a lot of these pictures are from the SCL 7A7 manual in Appendix F. I just want to give them credit for the diagrams. So let's go ahead and jump right in. As I say before, let's do the easy one first, which is going to be our Y. The Y is it's got that neutral point, right? So let's just knock that out. That's on our negative polarity side. Remember, each of these little dots right there, just like they're over here, represent. All right, there's no wire connection like it is right there. Okay, this is a wire connection and a polarity dot. The squares are the polarity dots. Okay, and so we're just going to go ahead and identify our polarity. This is A phase. And I'm going to do capital A because this is the primary. So this is capital B. And then this one is capital C. And then we also know that this is the Y. So we can just go ahead and make our neutrals right here, right? And there it is. Okay. So there's our neutral. And if a neutral came out, it would just come straight out here and go to neutral. There's nothing special about it. Okay, it's just that this one doesn't have the neutral pulled out. That's all. Okay, and if it was, it would be a YND1. Okay, just to be absolutely clear about that. So the delta, right? As we said before, the problem with the delta is that you need to identify what your connections are. So this is in that SCL 587 manual. It was it's a YD1. In Appendix F, they identified that the setting according to that, and some other relays and devices might call this a YDAC transformer, which means that this A phase terminal on the delta connects, right? And the reason why we say A is because we always use A phase as our reference for everything, okay? So our A phase, and we know why we don't have to worry about that. The other side connects to neutral. What we care about is A phase on the delta side. And the A phase on the delta connects to A and C phase. So it's actually the delta is A minus C. And if you look at this one, it's going to be connected to the A phase. That's the positive polarity of the A phase coil. So that's A plus. And it's connected to the negative polarity of C phase coil. Okay. Which is the same thing as doing positive A plus a negative C, which is equal to A minus C. That's how we get that stuff. Okay. So I'm trying to be very thorough in this, so that way other people can maybe be enlightened, right? So let's go ahead and let's take a look at this. We already know that our A phase connection, little a is going to be our positive polarity, little b is going to be our positive polarity, little c is going to be our positive polarity. So where can we make this connection? Well, what's the negative polarity of A phase coil connected? Right here, negative polarity of A. This is our A phase positive. This is our A phase negative, connects to B phase. So that one just got really easy. And then B phase coil, the negative polarity side, let me get rid of all this other garbage. The negative polarity side of B phase connects to the positive polarity of C. So that one just got easy too. And the only one that's hard is that we already know there's only one possibility left. It has to go up here to A, right? And if you want to trace it, the negative polarity of C phase right here connects all the way to the positive polarity of A. All right, so now that we have that, let's go ahead and let's draw out our Y diagram, right? And our Y is going to look like this. Well, you know what? In all the other videos, we followed the same convention where A is up. You don't have to. On your relays, they're going to essentially put A directly to the right. Okay, so let's just do that here because there's no difference. Okay, and we're going to take B phase. It's going to be right. Well, that's not exactly where B is. B should be more like, there you go, maybe down there somewhere, right? So B, and then C is up here somewhere. So C. All right, there we go. And hopefully that's good enough. And then where is our other connections, right? Well, we have VA and VB and VC. Well, what about on the delta side? Well, let's look at our delta. How this is, I said this in the last video. These are not our phase voltages, okay? These are our line voltages. And that is the purpose of this diagram and this clock shift, is to show you the phase change of the line voltage of the primary to the line voltage of the secondary, not the coils. We know that this A phase is in phase with this A phase coil. They're exactly in phase with each other. Okay, they have to be. That's just physics. Okay, but the thing is that what we don't know is what's the phase change when we jumper A phase here down to B phase or C phase. Okay, that's what we don't know. So that's what we need to figure out. So this A phase is connected, and like we said earlier, right, is connected from A right here and to the negative polarity of C. Okay, so that means that this is going to be hooked up as VA on the secondary is equal A phase coil right here and the negative polarity of our C phase here. Okay, and so that means that it's VA, big A, minus VC. And if we draw that out, what we'll get, and I'm gonna actually reduce each of these by half, so that way we can make this look a little bit more appropriate. Okay, and so we're gonna have VA right here, and then minus VC down here. And so then we have a total, well, that's kind of a curve, a total vector sum right here. And that's going to be our, actually, I'll leave those in there. And that's going to be our total V little a, okay? And then what do we have? Well, we have VB, and let's just go ahead and do the math real quick. VC equals, and I'm going to get my purple out. And so we have, this is going to be V. Well, we know that all of these are going to connect to the same polarity on the other side. So this is going to be a big B and this is going to be a C. And if you're not sure about that, you can just look directly across. Little b right here also connects right here, which is the same as the B phase polarity over here. It just carries right through on the transformer, okay? So that one's the same, and it's the same on the other one. What we need to figure out is what the other jumper connection is to, right? And this one right here is connected to the negative polarity of A phase, okay? So this is minus VA. And then the C phase one right here is connected also to the negative polarity of B. So minus VB. And if we go ahead and we get our red back out, and so our secondary is all lower cases. Remember that. That's the secondary here. And I'm going to get rid of that and this. So the secondary is all lowercase. Let's do our VB. VB is going to be out this way, and then minus VA, which is out that way, okay? And then we're going to have a total vector sum right here, and this is going to be our VB, V little b. And then the last one right here is going to be VC going halfway out, and minus VB, which is the other direction right here. And so that's a total vector sum of about that. And I know that this is not exactly what it should be, but it's pretty darn close. And this is going to be V little b. And now we can get rid of all these little halvesies in here, right? So there's that. But remember that the secondary is actually a delta, all right? So let's go ahead and draw this delta back out, right? And then we can get these Y voltages out of the center here. And now we can see what we had before, right? And so all we did was we just rotated this delta. If you were to take this, and this is A and B, well, let's do the same colors, right? Let's go ahead and just do purple A and B and C, and this is A, B, and C, and you superimpose this same triangle right here, okay? So that means that we're just going to take, well, we go straight out and it goes straight up this way right there. Okay. And this is little a, little b, and little c. What you'll see is that from here to here on B phase, you have 30 degrees, and big B right here comes first and then little b. And the same thing for A phase. Oh, look at this. Big B comes first and then little b. And it's all we did was we just rotated this whole triangle about what, 90 degrees. Okay. So that's all we did. Really, everything ended up exactly the same. We just changed our reference point to A phase being at 0 degrees versus over here where A phase was at 90 degrees. Okay. If you look at the primary of this one right here, A phase is straight up at 90 degrees. That's all we did by redrawing it in a different fashion. Okay. So hopefully that helps. Maybe